Hi guys, Jay Paranjpe here. Today we'll talk about the quadratic equations and their different graphs. So first of all, we'll see the general format of a quadratic equation, which is fx equals ax square plus bx plus c. Here x is our variable and a, b and c are our constants. Now we know that in the quadratic equation the power of x, that is the maximum power of x, is 2, and so the maximum real roots of this equation is 2. Please note that I said the maximum number of real roots is 2. Hence, the roots of a particular quadratic equation may be 0 in number, 1 in number, or 2. Also, the graph of a particular quadratic equation is always a parabola. This mathematical structure is known as a parabola. We'll talk about this a little bit later. So, depending upon the number of roots, that is 0, 1 or 2, as well as the sign of a, there are 6 types of parabolas, that is 6 types of graphs available for a particular quadratic equation. These may be number 1, number 2, number 3, number 4, number 5, and number 6. Here, the horizontal lines are all x-axis. That is, the area will plot the values of x. In example number 1, we see that there are two roots of this equation and here a is greater than 0. In number 2, we see that there is one and only one real root of this equation and a is again greater than 0. Here, there are no roots of this equation, rather I would say no real roots of this equation, and a is greater than 0 once more. In number 4, we have two roots, but here a is less than 0. In number 5, we have again a single root, but a is less than 0. And in number 6, we don't have any real root, and once more a is less than 0. So let's example of each of these 6 graphs. So yeah, let's talk about our first example in which we have a is greater than 0 and the equation has two real roots. One very good example would be x square plus 3x plus 2. Now let's plot this graph. So here, if we factorize x square plus 3x plus 2, we can write this as x square plus x plus 2x plus 2. This will be equal to x plus 1 plus 2, x plus 1, which is equals to x plus 1, x plus 2. Hence, the roots of this equation are x equal to minus 1 and x equal to minus 2. As you can see in this graph, these 2 points are the points where this graph crosses the x-axis, that is x equal to minus 1 and x equals to minus 2. This point is minus 1 comma 0 and this point is minus 2 comma 0. This U-shaped curve is known as a parabola and every quadratic equation is represented by 1. So, this quadratic equation has two roots. It cuts the x-axis at 2 points, which is minus 2 comma 0 and minus 1 comma 0. And since a is greater than 0, so it is a upward opening parabola. Now let's try the second example. Here we have a is greater than 0 and 1. For example, x square plus 2x plus 1. Now let's try to plot this graph. Here we have it. So in this case, we see that the graph touches the x-axis at only one point, which is x equals to minus 1. This point is minus 1, comma 0. Such equations are called perfect square equations and they have one and only one real root, in this case x equals to minus 1. Now let's go for the third example. Here we have a greater than 0 but no real root will be there. For example, x square plus 4x plus 5, and the graph looks something like this. We have plotted it from x equal to minus 6 to x equal to 1, and the graph nowhere crosses the x-axis. That is, there is no real root to this equation. So we have so far covered three types of graphs of the quadratic equations. In all of three, a was greater than 0. Hence, the shape was an upward opening parabola. In first case, it cut the x-axis in 2 points. In second case, it cut the x-axis in 1 point. Rather, it just touched the x-axis at 1 point. And in the third case, like this one, it does not cross the x-axis. Let's check out the fourth example where a will be less than 0 and there will be two real roots of this equation. For an example, we get minus x square minus 3x minus 2, and the graph looks something like this where x equal to minus 2 and x equal to minus 1 are the two roots of this equation. So this point is minus 2 comma 0 and minus 1 comma 0. The interesting thing about this graph is its difference from the first graph where a was greater than 0, there were two real roots, and the example we took was x square plus 3x plus 2. This was our first graph. So if you see the difference, it's just the mirror image of the previous one. Hence, just a negative sign before the bracket changed the graph shape from an upward opening parabola to a downward opening parabola. Here a was equal to 1, which is greater than 0, and here a is equals to minus 1, which is less than 0. Thus the sign of a makes the difference in the shape of the parabola. If a is negative, then it will be a downward opening parabola. If a is positive, it will be an upward opening parabola. The fifth example takes us to a less than 0 and one real root. Example minus x square minus 2x minus 1. Here also we see the shape of the parabola is downwards opening and the root is minus 1 comma 0. So at x equals to minus 1, this graph touches the x-axis. The mirror image of this graph is the second graph which we saw earlier, which was x square plus 2x plus 1. Here also the root is minus 1 comma 0. Here also we see that the difference is the sign of a. Here a equals to plus 1 and here a equals to minus 1. Otherwise the graph is same. Now let's go for a sixth example. A is less than 0 and no real roots. The perfect example is minus x square minus 4x minus 5, whose graph is drawn here. Here we see that it's again a downward opening parabola and it does not touch the x-axis. Its mirror image is the graph of x square plus 4x plus 5. Here a is greater than 0, which is 1. It also does not cross the x-axis, but it's an upward opening parabola. So now let's make a quick summary of what we learned. First point, there are 6 types of quadratic graphs. They can be divided into first, a is greater than 0, and second, a is less than 0, where we have the general form of quadratic equation as ax square plus bx plus c, where this a and this a are the same thing. So the first case here is two real roots. The graph is something like this. Second case, one real root. Graph is something like this. This is only one intersection point. These are two intersection points. Number 3, no real root. Here the graph will not cross the x-axis. Similarly, in the second case also there are 3 sub cases. First is two real roots. Graph will be something like this. Also touches the x-axis at 2 points. Second subcase, one real root. There is only one and only one intersection point. Third case, no real root. Here the graph will not cross the x-axis. A is greater than 0, hence the shape is an upward opening parabola. A is less than 0 and hence the shape is a downward opening parabola. So, hope you enjoyed this session. Thanks a lot.